Okay, so this is for Hythlo Day and whoever else. I'm responding to his request for more specific purpose about why we should have a conversation about economics. So I always say with purpose to, there can be more than one. Hythlo Day is saying, hey, we should try and narrow it down to one so we can achieve some common goal. If we have specific goal, then we'll know when we've accomplished what we're trying to achieve. And I think the goal is, try to make people better off, but it's more complicated. So, one goal is fun. Like if we aren't having fun in these conversations, then we won't do them. So that's going to be a pretty high goal, is that we got to have some fun or it's going to stop. And if it's not fun, then it's probably not worth doing. But also goals, we need to narrow the conversations. We're talking about something specific. But it's still a conversation about reasoning. The economics is just a medium because I'm to talk about reasoning, because I certainly know it better than quantum mechanics. I think it's more intuitive as a thing to talk about. That there's a lot of play in econ, there's a lot of drama. That physics is going to be a very hard science. It's going to be either right or wrong. Where economics, there's going to be more drama. So it's an interesting medium to talk about reasoning in. And so as far as reasoning goes, I want to try and convince you today that pictures are valid reasoning. That drawing a picture is perhaps the ultimate form of logic. Because it quantifies it, but we'll get, and it's easier than logic too, but we'll get more into that later. Another goal for today is, again, I want to use more econ examples. This does stuff for me where I can go through my notes and review things and kind of put things more solid in my own mind, which improves the reasoning of myself and improves the video making skills of myself as the better I get doing this, and also for the viewers, that hopefully they will learn something from it as well, and learn how to build some models and think about things as pictures. Part of the goal is conversation, that I find that having the conversation pushes me, that Hythlo Day is going to say some things that are going to get me to make more videos to try and respond with what he's saying. Things he's talking about is allocating resources. We're going to talk about that today. That he's been kind of saying, well, that's the goal of economics. I keep talking about, in my videos, there's always all this demand side stuff that I talk about, as far as desires and utility and what people do and how they're going to make decisions collectively and this kind of stuff. And that's all demand side stuff. And he's like, well, there's economics. We should have some, goods being produced. So we're going to do some production models today and allocate some resources. He's talking about utopia building versus, he's like, hey, should we talk about these utopias that are going to change the world, or we don't really have any power to change the world, or should we talk about more specific issues like Greece, where we might actually be able to do something? I think it's pretty unlikely that I could say something that would change what Greece is going to do, but we can certainly talk about it. The thing that I'm trying to say today is that the models that we're going to use to talk about utopias and talk about problems in Greece are the same models. That the general models can be applied to specific cases as ways of thinking about them. I'm not going to get to economic sanctions. We're just going to build one country today, and not going to have trade between two countries. That might be the video after this if we go farther. But we're going to do a lot of mapping. I think they just posted we were in the Hangouts, and he posted a link to a video about mapping between string theory theories. And so we're going to do a lot of mapping between theories today, so that should be kind of fun. Okay, so utopia building. We're going to talk about allocation. He says allocation of scarce resources among competing ends. And I'm going to say that doesn't work for me as a goal, right? Like, I'm going to have 4 guys here. I'm going to give guy A 2 resources. I'll give person B 513 resources. I'll give person C no resources. You get none, C. And I'll give person D 12 resources. I'm done. I just allocated the resources among competing ends. Oh, but I didn't use any reason. It was completely arbitrary. So part of our goal has to have reason. We're going to need that as to why we're giving the people the different amounts of resources. It's got to be something about better. We're trying to make people better off. But then, what does better mean? And we get back into ethics and philosophy. Like, there's things like efficiency and fairness and suffering and all these kind of measurements. And depending on which measurement you use, United States might be the best country, Norway might be the best country, Japan might be the best country, China might be the best country. It's going to be different depending on which measurement you use is going to change the result. So it's going to be tricky. We haven't really defined what better is, and I think as far as that's kind of the goal here. I think that's the specific goal we're trying to get to. But we're going to try and get there first. So we're kind of back at the beginning with Michael Sandel and Meham, all this kind of ethics stuff. And how are we going to figure it out is drawing a picture. But first, talk more about resources. Draw a picture of resources, and there's going to be start thinking about things that we might want to put in this picture, right? So we talk about scarce resources, so it's going to be costs in getting the resources, and costs in producing the resources into secondary goods, and this can be in units of money or energy. It doesn't matter. It's easy to map between money and energy. We can put a price on it. Technology is important. What technology does is creates more output per input, and it's a function of time. At any one given time, technology will be fixed. But over time, technology can improve. Technology can even disimprove, but not very often. Usually, technology gets better over time. And there's going to be different costs. There's going to be fixed costs. And fixed costs can be a function of time. Like they're fixed in the short run, but over time you can, with capital you can change the fixed costs. Variable costs are more about labor, and this you can change in the short run. Kind of hire and fire people and hire some temps or whatnot, and change the variable costs in the short run. Now, when we draw a picture. We create a possible world, right? Especially if we draw a picture on a graph. Then we've got something quantifiable. So things we can put in here are like economies or physics, like particles floating around up in this space here. Or we can graph a logical theory into one of these spaces. We have another space, right? This one's in terms of X and Y. And here's an economy 2, or a different something else, particles in this space, and we can make maps between these ones. Like here's possible mapping is y equals z plus 1, so for every 1 this goes up, this also goes up 1, but it starts a little bit higher. Or x equals 3 times q means that this q space is more squishy and this x space is more spread out. For if x is 3, then q is 1, right? And if x is 6, then q is 2. And so we can create a mapping between the two spaces. It either requires to have the same variable, in which case it's a one-to-one mapping, or it needs some kind of mapping between variables. And so this can move between different dimensions, and between different theories, between different utopias, different models of countries. So now we'll start thinking about production, and To do this, we're actually going to produce something real quick here. Going to make some orange juice. Just as an example, we'll take the orange juice out of here, put it into here, get some water. Stir it up. I'm not going to waste your time stirring this up too far. That's pretty good. Boom. Perfect. Okay. So we produced our orange juice, and now we're going to talk about that experience, that observation. We produced 1 unit of orange juice, and it had a certain amount of costs to it. Like, here's our costs on here. Costs can be money, right? It took me some money to buy the orange juice and the water, I guess. Some energy of me mixing it up, and a little bit of time. Now, so there's a vector, right? It's a three-dimensional vector, but all these can be converted into costs, into dollars, and then we can find the distance of that vector by taking the square root of the sum of the squares. So we'll square all the costs, add that up, and then take the square root of that, which will give us a single cost, which we can then mark on our cost line here somewhere as a single number. I'm going to say here the cost is $500 because my time as an economist was so important that that's a $500 glass of orange juice. Now, if the price is above that, then I'm going to get some profit. Yeah, if the price is lower than $500, I'll get some loss, and that means that me producing the orange juice was unfeasible. And I can kind of think about, well, what if I produce 2 glasses of orange juice? Then I could do this and this, and I kind of have the straight line. Like if I produce 0 glasses of orange juice, it doesn't cost me anything. 1 cost me $500, 2 cost me $1,000, and so on, right? Basically, I get this purple line. It's a straight purple line. That's my total cost for orange juice, right? If I want to produce 3 glasses of orange juice, it would cost me this much. So we've got our first theory. There's Pythagorean theorem. That's how we did this. So here's our picture. This is our theory. And so basically, our theory is that that each quantity of orange juice is going to be 500. It's basically like 500 times the number of orange juices is what it's going to cost, is our theory. And so is this valid, right? We just drew a picture. Does that mean it's a valid theory? Is that logical? If so, is this one logical? This total cost curve that goes all crazy, it's not even functional because there's doesn't pass our straight line test or horizontal line test. It's just some crazy theory. Is that functional? Well, the thing is, it's a risky prediction, right? We can look at the world and see if it goes like this. So therefore, it's a valid theory because it's a risky prediction. Even though it's not very reasonable, there's no theory as to why we would expect this. It might not even be possible for this to exist. But we can test it because it's on a graph, because it's quantified theory. Here's the one we came up with. We use reasoning. It seems possible. It is functional. And it's a risky prediction, right? And here's our theory. It's the cost is 500 times the amount of orange juice. And so then the math can be used with observations. And we can falsify our theory, right? First of all, it starts at 0, 0, right? And if we use this cost theory and take it to, let's say, the Pepsi plant where they make the soda cans, they'll be like, well, you know, if we produce 0 cans of Pepsi, we still have to pay the rent on the plant. There's some fixed costs So our theory doesn't account for fixed costs. And we didn't really think about the curve. We said it would cost more to produce another one. But there could be agency problems, where if you get a bunch of workers to make the orange juice for you, they might be slacking off, and so the more you output, the higher the costs are going to be. Or there could be gains in coordination, right? That we hire more people, and one person can put the orange juice in the cup, the other one can put the water in the cup, and the third one can stir the cup and gain some coordination. So there could be some bendiness to the curve as well when we look at the real world. But it was confirmed that the general idea of the upward sloping total cost curve, that when we look at the real world, we don't find that it costs less to produce more. So we can create a new picture, right? So it's basically the same picture. We've got our total cost curve on an upward slope, but this time we've now got it starting at our fixed costs. Now there's things we could add to this. We could have time coming out as a third dimension from the model, and then we could talk about technology, and make falsifiable claims about technology, whether we think that over time technology could do some things like it could lower the amount of fixed costs we need, and it could also lower the slope from the purple line, that we could produce more for less. And that over time we could even change the fixed costs and this kind of stuff, and how this thing might kind of wave outwards in time. But we're not going to get too much into time today. I just thought I'd bring that up. Is we could add that to the model, but today we're just going to look in the short run. And so we changed the picture, so that changes our theory, right? So now costs are going to be the variable cost times the amount of orange juice. So it's like 500 times the amount of orange juice, like we had before, plus the fixed costs, and so that's some y-intercept. We haven't changed the theory much, but it's more complex. So then what we want to do is, we've got the total cost curve. Right here's our total cost curve, and we want to change it into the average cost curve. Now to take the average, here's our theory, right? Was the variable cost times orange juice plus the fixed costs, and so that's the total cost. And so then if we divide that by the quantity of orange juice that we have, then and we could put some curvature on the orange juice too if we wanted to, but mostly I'm ignoring that. But we divide that by the orange juice, and that gives our average cost. We'll do some math with this, right? So there's a plus here, and this common denominator, so we can make this into two fractions. So we've got variable costs over orange juice and fixed costs over orange juice, and we can do some canceling here now. So it's now variable costs times 1, or variable cost times orange juice, but the x curvature of the orange juice has been reduced by 1 because we subtracted this orange juice from it. And then this is still going to remain fixed cost over orange juice. This part stays the same. But now we've got it in these two parts. We can think about this part. This will get larger as orange juice goes towards infinity. Or it'll go 0 if orange juice is 0. Where's that one? It's the variable costs. Is here, right? So it basically starts at 0 because we've taken the fixed cost part out of it, and it has the same slope as the total cost curve did before. Whereas this part, the fixed costs over orange juice, that's going to be larger in the beginning because fixed costs are big and orange juice is going to be small. And then as orange juice approaches infinity, it's going to get smaller and smaller and smaller. In fact, this will be infinite if orange juice equals 0, and I think it's 1. It's equal to the fixed cost if orange juice equals 1. So when orange juice equals 1, here's the fixed cost, and from there it goes up to infinity, and here it goes together. Now again, it was this plus this, so we're going to add this graph to this graph, and here's what we get, right? Here's the part where it's large in the beginning. Basically, this guy here has more effect in the beginning, and this guy here has more effect in the end, right? So we start out, this guy's more important, and we end up, this guy's more important, and it creates this shape. And this average cost curve is what's known as the supply curve in economics. Often people just draw an X, but I think that this curvature is very important for finding the monopoly price, as we'll see in a minute. So this goofy looking guy is the cost curve, and so now we're producing some units to distribute, some goods that things. So we're going to put the demand curve on it first to put the goods in there. And quick review of that, we said utility was some function of square root of the amount of goods, some scalar multiple of the square root. Because the more goods we got, then the less happy we got. We get more happy from each good, but less happy from each good. It's kind of diminishing utility. And we would take the derivative of that to find a per cost, a per unit utility, which relates into willingness to pay. So x, the square root of x becomes 1/2 x to the negative 1/2, or rewritten 1/2 times the square root of x. And that is equal to our demand curve. It's going to be some scalar multiple of that for the quick demand calculus review. So now we're going to put them together, right? Here was our 1/2 times the square root of x for our willingness to pay, the demand curve. Here was the cost curve, the average costs. And so we put them together, and here's where our supply equals demand, marginal benefit equals marginal cost. Boom, we have just created an economy. It took a little bit to get there, but we did there. And so along here is going to be the price. Here's better than the quantity. And here's the point of that they call efficient, and so this would be the efficient price, and then this would be the efficient quantity. Oh, and so we can find this point is when these two things are equal to each other, when the green line is equal to the orange line. So the green line was a scalar multiple of, or the scalar multiple is based off our preferences over, 1/2 times the square root of orange juice. And then we set that equal to our average cost curve, which was the variable cost times the quantity of orange juice plus the fixed costs divided by the quantity of orange juice. We set these guys equal to each other, and we can solve for orange juice, and that's the efficient amount of orange juice that I should drink and make for myself. Okay, so that's an economy of one person. We want to talk about countries, and we're going to cheat a little bit. We're going to just kind of add up a bunch of different producers and make it a goods market. It's just all the goods the country produces. And this is an aggregate demand curve, where this is like the sum of all the individual demands. Now, in one of my Inventive BS videos, when we was talking about demand, I said that you could not do that the social demand curve is not the same as adding up everybody's individual demands. In fact, you can't even map it together, is what I said. And here we're just going to go ahead and and do that. Now the thing about this is it's actually easier empirically to measure the aggregate demand curve and how much goods a society demands. That's a more measurable thing than an individual demand curve. So in some ways, yes, we can do this. In some ways, there's a theory saying we can't do it. But until there's something, a better way to do it. Like one way we can do it is we can take, find an average consumer, the average consumer in the country, and then multiply their demand curve by the number of consumers in the country, or we could integrate that demand curve and create an aggregate demand curve. It's really tricky. There's a whole lot of weird philosophical stuff that goes on here. But today we're just kind of going to draw a supply and demand curve for a country. Now we made this crazy cost curve, and that's important, right? So this is the producer's utopia, and where the producer wants the price to be is here. He wants to produce this much, and they'll be willing to pay that much, and so he'll get this whole box in profit, right? Where under the theory of perfect competition, we can get an infinite number of firms. Like, this is kind of Zeno's paradox, right? Like if one firm has all the market power, it'll produce here. But we add in a second firm, and then they kind of compete each other into a little bit into producing this much, and then this would be the cost. And then the third firm would produce this much, and it gets closer and closer and closer. We would need an infinite number of firms to get to this point. And so here is a place where Zeno's paradox actually does apply. Is that there's, we have to go here, like it would take an infinite number of firms to get the price equal to the cost and the profit down to zero. And so producers are not going to want that. Producers want to get all this profit for themselves. Bang. Now, a politician's going to have a different utopia. I'm kind of saying that he's going to want it in the middle. Like, here's where the producer would want it. Here's where the consumers are the happiest. Here's the consumer's utopia. Now, when it's in the middle, the politician can maximize campaign contributions. That he can gain popular votes from people by setting a price, by doing some regulation, setting a tax, or some of these mechanisms they have available, monetary and fiscal policy, to move how much is produced over here, or set a price so that it's over here, and that'll get votes from people. He can also set it over this way towards where the producer wants it to be, and get campaign contributions. Basically, he can get campaign contributions from going either way. He can either, try and get campaign contributions for offering to set the price over this way where the producers want it, or he can get campaign contributions by threatening to move it to where the consumers want it, and then not doing that, like just making a threat, and then they contribute to his campaign. This kind of seems like it's corruption, but it's not. Politicians absolutely need campaign financing. They're not going to keep any of that money. It's all going to go to their advertisers. But anyways, he's going to try and maximize votes by setting a price such that the area that the producers want is equal to the area that the consumers get. And he can get a lot of campaign contributions from this, right? Like here, he's somewhere in the middle, like maybe there's 3 producers. Here's how much profit they're going to get, and they're going to have to divide that amongst themselves. Producer 1 gets this much, producer 2 gets this much, producer 3 gets this much. Whereas if you set it to a higher price, then maybe it's just going to be one firm, and they're going to take all of that big box for themselves. And so there's a lot of ways he can squeeze campaign financing from the market. And so that's kind of what's been going on in Greece there. I mean, it's very oversimplified here, but that's kind of what I was trying to get to today with building this economy. Is that we haven't even gotten to two countries yet, but here we can there's some interesting stuff as far as what a politician can do in their own country. The various tools that Greece can have, and it's kind of similar to Colorado, where there's a larger government. So like both Greece and Colorado can collect taxes, they can issue subsidies, they can do fiscal policy, which is how much government spending they do. They can't do monetary policy because they don't create the money supply. That's done by some central bank that's controlled at the higher government level. And then they can maybe do some price controls or various tools they might have to affect the economy. So Greece, I think, is talking about having some universal health care. There's going to be, for monetary policy, they can still do some borrowing, right? And Greece can borrow money and then do fiscal policy and spend it. All the fiscal policy all comes from taxes and borrowing. It's where governments get their money to be able to do government spending. And it's going to get really complicated really fast. So this is a model called the ISLM model. And it's really confusing. I'm going to go through it really quickly. We spent spending months on this like econ students usually do. Here's the economy that we had. Here's an amount of goods being produced. Here's demand for those goods, and some price being this come out of that. And this is all under assumptions of equilibrium, which is often not a good assumption. And there's no consensus on any of this macro stuff. There's a big debate on what's the right model and what are the effects going to be and all this kind of stuff. But there's some things we do know. This is pretty well established, right? So we've got our price, and it relates through a mapping to this guy, which is the interest rate and the savings, the amount of savings in a firm. If the interest rate is high, people will save more. If the interest rate is low, they'll save less. And savings equals investment. The money you save, you put in the bank, and the bank invests that in the stock market, or you can invest money in the stock market directly. But the amount of savings has a one-to-one correlation with investment. So this curve is an investment curve. It depends on the interest rate, the amount of savings. And then this one is a preference for liquidity. That if the interest rate is high, then we want more cash. It's a really strange one. But it relates to money demand through a mapping. Here's our money supply, and it's a certain amount of money supply of money over divided by the price is what we're mapping. I don't understand this macro stuff much at all. And then there's some downward sloping money demand. This is the interest rate on this side of the graph. Like these three maps are put together, right? But the idea is like if we increase the money supply and move it this way, then that would make this point come down here, and we'd match up to this curve, which would then, we'd hit investment first. We'd come down here. Okay, let me do this again. We move money supply this way, right? We create more money supply in an economy, which moves this orange line so that it comes along here, hits investment. And then through the theory of equilibrium, this blue line is going to come down to match it, which would then come up here and hit this orange line, and the supply curve is going to adjust to meet that. And so that's how an increase in money supply is going to have an increase in production, which would decrease the price. I know it sounds crazy, right? But there's so many videos on YouTube. They're talking about what's going to happen in Greece, and if you print all this quantitative easing and things the Federal Reserve and the central banks are doing, that they increase the money supply, and that's going to create inflation, which is going to increase the price. That seems like so intuitive, right? Oh, we make more money, inflation goes up. That was Francis Bacon's first observation about economics. But here we're saying that that isn't necessarily true, that it might just increase the interest rate instead of increasing the price, or it could increase production and decrease the price. There's a lot of ambiguous effects here on these macro models that just get pretty crazy pretty fast. And one thing I'm kind of saying, if there's someone out there that's got a simple answer for what Greece can do, they are either delusional or lying. There's a lot of things to consider here, and all these people that talk about, oh, don't trust the reserve and shut down the reserve, they never talk about effects on the interest rate. They just assume that increasing the money supply is going to increase the price, increase inflation. But there's a whole lot of things that they're not considering there. It's going to get really confusing really fast. One thing we might do, I try to do this is how I got through macro class in school, was making these input-output matrices. So we've got our inputs over here, like here's production and aggregate demand, prices, and the government borrowing, spending, money supply, all this kind of stuff going on over here. And it's the same list going across the top here, and they're not going to affect themselves, right? We're going to put a dot if there's no interaction. We're going to put a negative sign if, like, here's production and prices, and the more you produce, price goes down. So there's a negative relationship there, right? Where if it was a positive relationship, I would have put a plus here. And so how this is going to work, right? We're going to increase the money supply. Again, that's something that Greece can't really do, but it's just a thing. And I haven't filled in most of it in, but oh, look, when we increase the money supply, then people's preferences for liquidity is increased, right? So then we come down to preference for liquidity. Oh, and so that creates a negative in prices. And then prices, oh, I guess I need to do that. Okay, so, but that's just kind of how the idea is. It's once we put in some input, find out what outputs it's going to change, and then we have to put in those, like they all change. So we then put those outputs as inputs and see what then changes, and try and see if what the effects of some government change in the economy are going to be. It's going to be tough, but I tried to show this. I had this mostly filled out when I was in class, and I showed it to my professors, trying to say, "Hey, can you help me get these squares that I'm missing here?" And they just looked at it and they're like, they thought I was crazy, but it's not a bad model. It doesn't, it requires, one of these guys to try and figure out what the relationships are going to be, but then. This was my study guide, my go-to kind of model of an economy. So, okay, 40 minutes. That was the purpose. We introduced models for Greece. There's a lot of these things we can talk about Greece, even in a one-country utopia kind of model, right? We didn't add a second country yet. And yet there was a lot of interesting stuff that we could talk about in the one-country model. So we didn't need to get into multiple countries, but that's certainly a complication we can do. We can add time to it, which is interesting as well. But we've gotten the tools. It wouldn't be too hard to build a second country and map between them and see what the trade interactions between the countries are going to be. We talked about money supply and exchange rates and trade, and mapping between countries. That's my video on purpose. I hope you liked it.